Hi and welcome to our channel. Here we are discussing valves and related topics. In the last video we discussed cavitation and today's video will be discussing about flashing. This topic is essential for engineers, plant operators and decision makers in various industries like power plant, chemical, oil and gas, water treatment, etc. Both cavitation and flashing are closely related. The major difference is that when the outlet pressure recovers and is higher than the vapor pressure, it will cavitate, while for flashing, the outlet pressure does not recover and is less than the vapor pressure. As you can see in this figure, the blue line refers to the pressure that does not recover and it is below the vapor pressure. A lot of engineers get confused between cavitation and flashing. Let me show another figure. Here you see there is a normal flow, there is a cavitation and there is flashing. As you know, the cavitation can be eliminated by using special trims. However, there is no solution for flashing. It is a process limitation for flashing. One of the main reasons for flashing is that when the vapor pressure is high, which depends upon the temperature of the fluid. It means if the pressure drop is high and the temperature is high, flashing will happen. While if the pressure drop is high but the temperature is much lower, then cavitation will happen. Before we discuss about flashing damages and solutions, we should calculate the percentage of flashing, which is equally important to know what kind of solution we can provide. As you can see in this equation, percentage of the flashing is basically calculated as the difference of specific enthalpy of fluids at inlet and outlet divided by the latent heat of vapor. For our simplicity, let us assume that we are considering water and steam. Then percentage flashing is the difference of specific enthalpy of water at inlet and outlet divided by the latent heat of steam. We can take a small example. Say if the inlet pressure is 10 bar and the outlet is 3 bar. We can calculate the percentage of the flashing around 8.26%. As you can see in this image, the damage that is done by flashing, do note that the damage is not severe as compared to cavitation. This is because the media has changed its phases from liquid to gas and the velocity is high. However, for the cavitation, the media changes its phase back to liquid within the valve itself, due to which bubble implodes, thereby creating much higher damages. Flashing leads to erosion, loss of control, noise, vibration and reduced flow capacity. Now, based on the percentage of flashing calculations, we can decide the solution. First, the valve size must be same as the pipe size. Many times it happens that the engineer is selecting an undersized valve. Second, the valve must be straight type or an angular type depending upon the percentage of the flashing. And third, the trim material must be selected to resist the erosion. Material like 17.4 pH, 316 with hard facing should be selected. Few of the valve manufacturers do recommend an eccentric rotary valve where the flashing is very high, because the rotary valve provides larger area for expansion of gases, which will result in much lower damages. So this brings to the end of our discussion on flashing. If you need a valve for cavitation or flashing or looking for any control valve, do contact me. Thank you.